At the end of this lesson, students should be able to 1. Derive the equation of wave, 2. Solve simple problem based on equation comparison. See you in the lesson. In this session, we shall be looking at the equation of wave. Now we're looking at the equation of wave. The equation of waves. Generally, given a wave profile, now we have a wave profile. Here we have our crest. We have our amplitude. Then remember that this x direction, this y direction. Now, if a particle starts from 0 and end at p, given that a particle make x distance. Now, for such a wave profile, we can write an equation for the wave. We can say that generally that y is equal to a sine psi. A sine psi. Now, for the particle to move from point 0 to point P, remember there are parameters. There are parameters that is gained as the particle move from a particular point to another. So we get to that. But however, we can write that psi is equal to WT. Psi equals to what? WT. So psi is a function of what? W and T, where W is angular velocity and T is what? Time. Now, if T is a function of time, it means that the particle started from what? At point T0, at point what? T0, and what? At point what? TP. Also, there is a change here. There's a change in the speed of the body. There's a change in time. So we can write here that, recall, the V is equal to what? X over what? T. We also have the T. When we make T the subject of the formula by cross multiplying, we see that here T is given by X over V. I want you to note this. But however, you see here that from 0 and P, between 0 and P, so there is a gain. We can have here that psi here is equal to what? W bracket T 0 minus what? CP. That's time at 0, time at what? P. Of course, we understand that at 0, time is not gained, but at P, time has elapsed. Therefore, we can express time in terms of the distance covered over what? V. So we can then write that psi is equal to W bracket T minus, in place of what? TP here, we can now write what? X all over V. Because at P, the time has gained distance and change what? Change in velocity. So now our psi becomes W bracket T minus S over V. So replacing this psi equal to W bracket T minus S over V with psi here, we can then have that our Y is equal to A sine psi. Y equal to, in place of psi, we can then write that A sine W bracket T minus S all over V. Now, this is an expression, this is general wave equation. But however, we can then write that Y is equal to A sine W bracket T minus S all over V plus alpha. Recall that we did explain in the previous sections that particles, they always move in phase. The particles, they move in what? In phase. They move in phase as the wave progresses. So particles, they move in phase as the wave progresses. So now we can, of course, we can call this equation 1. We can call this equation what? 1. We can build other equations from this simply by considering some factors. We can build other equation from this. But first of all, what are these factors? They are called simple formula in wave. Simple what? Formula in wave. So, all right, what are these simple formula? Let me write them down here, then I'll come back and do some derivation here. So, I'll write them. What are these simple formula? Let me write them down here. Now, the simple formula, we're going to say wave formula. Wave formula. I'll come back to the equation 1, because you need them to build this equation. I will have K equal to W over V. Here, K is wave number or wave constant. W is angular velocity, while V is linear velocity. That's number 2. We also have that W equal to 2 pi F, where W is angular velocity and F is what? Frequency. Number 3, we have F is equal to what? 1 over T. We saw that before in our previous session. Then T is equal to what? 1 over F. Then 5, we also have a V equals to what? Lambda F. 6, V equals to what? Lambda over T. Why do we have T here? Because here we see that if F is 1 over T, so we can replace F with what? 1 over T. So we have a V equals to lambda over T. Now, with these 6 simple formulas, we can build another equation. Let's call this, since this one is what? Equation 1. So that's 1, or I can decide to write 1 here. Then number 2, we have, let's expand this. When we expand this, we can see that Y is equal to A sine W times T, that's WT. W times 7 minus Wx over V bracket plus what? Alpha. Yes. Now we can see that from here our equation becomes, well, there's no longer bracket. The plus alpha, because we have opened the bracket, we have Ws all over V. Now from this simple wave formula, this parameter W over V, we start K is equal to what? W over what? V. So we can then have that Y equals to A sine WT minus KX. But K stands for W over V. Yeah, plus alpha. So we'll call this one equation 2. So we can refer to this as what? Equation 2. So this becomes our equation what? 2. We call it number 2. Then from number 2, we can also write, now from number 2, we can write, we can build from our original equation. Our original equation, which is what? Equation 1. We can develop equation 3. Our equation 1, we can develop what? Equation 3. We write Y equals to A sine W times T. Are we opening it? No, there's no need to open it up again. We just go from our wave formula. We see that W is what? 2 pi F. So we can replace W with 2 pi F. 2 pi F bracket T minus X all over what? V. Yes, plus alpha. That becomes our equation 3. From 4, again, we can then write Y equals to A sine. Again, from our simple formula, we that F is what? 1 over T. F is 1 over T. So if we replace F as 1 over T, we're going to have what? F equal to 2 pi over T bracket T minus S all over what? V plus what? Alpha. Yes, because F has just become what? 1 over T. It became 2 pi over T. So that is that. So we can also write for the equation what 5. Y equals to a sine. But how do we build equation 5? Where are we getting it from? So where do we get equation 5 from? So we look at it. So equation 5 will simply come from using this denominator 2 pi over t to multiply the denominator in the brackets. So that becomes 2 pi. 2 pi, we use t to multiply with you have t over capital T minus x over tv plus what? Alpha. Now this is our new equation, but however, this tv is too cumbersome, so we'll look for a single parameter to replace tv. And how do we get that? We come back to our Waec formula. We see here that from v equals to lambda over t, we can make lambda the source of the formula here. We'll make lambda the source of the formula from number 6. From number 6, we can make lambda the source of the formula. We have here v equal to lambda over t. If you cross multiply, you see that lambda multiplied by 1 is what? Lambda times 1 equals to what? V times t. So we have lambda equals to what? Vt. So this expression, we are going to replace it with what? Tv. We are going to replace what with t, what with tv here. So lambda equals to vt or tv. So we have y equals to a sine 2 pi bracket t over capital T minus x over lambda bracket. So we have bracket plus alpha. So we build that. So this one becomes our number 5. Let's take this as equation 5. So this one becomes our number 5. We take this as our number 5. So that becomes our number 5. So that is that. So that becomes equation 5. So there is need for us to have, okay, there will be need for us to have a further equation. We can have further equation. What we need to do to have a further equation so it can be 6 equations. We can do that. If we have lambda here, we can make both denominators lambda. We can make what? Both denominators lambda, so that we can have it. So let's do that. So let's do that. What do we do now? So we have to create space. Let's create space for that. So we create space for that. So we write equation from equation 5. Again, we write y equal to so we write from equation 5, we write y equal to a sine 2 pi bracket t over t minus x over lambda plus alpha. Now I want to replace t now with lambda. What do we do? So in place of t, so we build it with lambda. So we can have t. So we'll come back again to equation 6. I want to make t the source of the formula here. So we can have from here, from v equal to lambda over t, we can have t equal to, when we come to cross multiply, tv equal to what? Lambda times 1, and that's lambda. So if lambda equals to tv, we want to make t the source of the formula. I have t is equal to what? Lambda over v. Now have t equals what? Lambda over what? V. Lambda over V. Lambda over V. Then we are going to come back here. Now we have t at the solid formula here. So this equation now, we are going to replace this component. Look at it. This component now, we are going to replace it. That becomes what now? Since we have t equals to lambda over V, we now have t all over lambda over V. Lambda over what? V. So we can, which reads like this, t divided by, let me do like this, let me divide it and write it there. That means t divided by lambda over what? V. T divided by what? Lambda over V. That becomes t times V over what? Lambda. You get it now? T times V all over what? Lambda. So this expression now becomes, that becomes what? Vt over what? Lambda. So we can come back to our expression here and call it Vt over lambda. So our equation will now read, y equal to a sine 2 pi bracket Vt over lambda minus x over lambda plus what? Alpha. Plus alpha. So we're not done yet. Now let me write that again. Let me write that. Let me just use this space here. Or let me come back here. Let me come back. Let me write that equation again. The equation reads that y is equal to a sine 2 pi bracket Vt over lambda minus x over what? Lambda plus alpha. Of course, the numerator is the same, right? Y equal to a sine 2 pi, since they are the same, you factorize, that becomes 2 pi over lambda bracket Vt minus x plus alpha. So therefore, this becomes our equation 6. So we are going to write that y is equal to a sine 2 pi over lambda Vt minus what? X plus alpha. So that's our equation what? 6. Right, equation 6. So that is that. So in summary, we are going to write out our 6 equations. Our 6 equations. In summary, we're going to write out our 6 equations. So we're going to write out our 6 equations in summary. Haven't derived them, so let's know them. We're going to write out our 6 equations in summary. So what are the 6 equations? We have number one, we have what? Number one, we have y equal to x sine w bracket t minus s all over what? V plus alpha. Number two, we have y equals to a sine wt minus kx plus what? Alpha. Number three, we have y equal to a sine 2 pi f bracket t minus s all over what? V plus alpha. Then number four, we have y equal to a sine 2 pi over t bracket t minus x all over v plus alpha. Then number 5, we have y equal to a sine 2 pi bracket t over t minus x over lambda bracket plus alpha. Then the last one, number 6, y equals to a sine 2 pi over lambda bracket vt minus x plus alpha. Now in all of this, because wave can move either to the left or right, we can add plus minus, plus minus, plus minus, plus minus, plus minus, plus minus, then plus minus. So this is a summary of what the wave equation from number 1 to number 6. So, but we need to interpret the various parameters here. Let's quickly interpret them. We have here where y is equal to what? Y equals to vertical distance. S equal to horizontal distance. Then A equal to amplitude. A equals to amplitude. W equal to angular velocity. Then T equals to time along the horizontal. Then we have x, we have already explained x. Then v is linear velocity of the wave, or wave velocity, linear velocity or wave velocity. Then alpha v, alpha is phase angle. Alpha is phase angle. Then t is period. We have lambda is wavelength. Lambda is wavelength. So yes, lambda is what? Wavelength. So these are the various parameters explained. Of course, there is a parameter there we've not explained, that's pi. Pi is equivalent to what? 3.142, and is a constant. So far, that is wave equation explained and also derived and summarized. So in our next session, we are going to be looking at how this wave equation can be applied in solving simple problems. Thank you. In the lesson ahead, please be prepared to leave in the comment section questions and state area of difficulty. Looking forward to see you there.